You can graph functions of the form y equals the nth root of bx plus c using transformations, if you can simplify the radicand so that x has a coefficient of 1. This is also true for functions in the form y equals a times the nth root of bx plus c plus k. Problem 6. Rewriting a radical function. How can you rewrite y equals the square root of 9x plus 18 so you can graph it using transformations? Describe the graph. Consider what you might think on the left and what you may write on the right as you work through this problem. First think, the form y equals a times the square root of x shows the stretch or shrink, so we can factor to get x minus h in the radicand. And write, first the original equation, y equals the square root of 9x plus 18, and then factoring the radicand, that's y equals the square root of 9 times the binomial x plus 2. But recall we'd like to represent that binomial as a difference. Currently it's a sum, and so we rewrite x plus 2 as x minus negative 2. Now we have y equals the square root of 9 times the binomial x minus negative 2. Next think, find the square root of 9. Apply the square root to 9 in order to extract a 3 from the radicand. Now you have the form y equals a times the square root of x minus h that you can graph using transformations. The graph of y equals the square root of 9x plus 18 is the graph of y equals 3 times the square root of x, translated 2 units to the left. Your turn, part A. How can you rewrite y equals the cube root of 8x plus 32 minus 2 so you can graph it using transformations? Describe the graph. And part B, a reasoning item. Describe the graph of y equals the absolute value of 9x minus 18 by rewriting it in the form y equals a times the absolute value of x minus h. How is this similar to rewriting y equals the square root of 9x plus 18 in problem 6?